Y quisiera dar la bienvenida con un fuerte aplauso a Satish Rao, Managing Director en Clareo. Satish, welcome. Welcome to Peru again. The floor is yours, my friend.
Buenas tardes a todos.
Buenas tardes.
Thank you very much. It's a pleasure to be here. Thank you for the kind introduction, Manuel, and to the CIIT team for inviting me. So I reached Peru a few days ago. I spent a few days in Cusco in the Sacred Valley. What a beautiful place. Really enjoyed it. And flying into Lima, I was thinking that the accomplishments of the monuments they made, that great civilization, I think we're faced with a similar thing in mining now. We're looking at a digital mountain of sorts, and it's time to act and put all the pieces together to make sense and to create value for everyone going forward. My name's Satish Rao. I'm the managing director of Clareo. We're an energy and resources sector. I focus on mining and energy, and we work in strategy and technology innovation consulting. I'll be talking about AI, past, present, and the future. It's important to, before we appreciate what AI can do, I think let's travel back a little bit in time. As a graduate student in computer science, almost 35 years ago, I took courses in AI. Trust me, it didn't look anything like that, not even remotely. So what's actually changed? Let's try to evaluate and understand the fundamentals of what happened. And just in the last 10 years, in the last 10 months, in the last 10 days, and see what that might, where that might take us into the future. What does that mean for the industrials? Because all of these tools, they're fantastic for consumers, for you and I. Everybody has experienced ChatGPT in some form. And then what might a leadership playbook look like, right? So let me walk you through a little bit of a time scale. But first, does anyone recognize who made these statements and when? When wireless is perfectly applied, the whole Earth will be converted into a huge brain. We'll come back to that. Which in fact it is, all things being particles of a real and rhythmic whole. What a beautiful thing to say. It was a statement made by an engineer. Really, really proud. We shall be able to communicate with one another instantly, irrespective of distance. Not only this, but through television and telephony, we shall see and hear one another as perfectly as though we were face to face, despite intervening distances of thousands of miles. And the instruments which we shall be able to do this will be amazingly simple compared to a present telephone. A person will be able to carry one in his vest pocket. Anyone who might have made this? And when? 100 years ago. How incredible is that? So one of my favorite engineers, scientists, physicists, Nikola Tesla, made that exact statement. It published in an interview in 1926. It was 100 years ago. And it took 70 to 80 years for all of those things to come into fruition. And we're just about reaching the huge brain part. So there's lots more to come. So why does it feel, if he was able to look back and realize where things were going, why does it feel so hard for us to tell what the next 10, 20 years could look like? So let's go back to what I said and evaluate and understand the fundamentals. So a lot of this has to do with compute power. I follow, I think, one of the equivalents of those greats. There are a few today. I personally really enjoy watching Jensen Huang of NVIDIA, who has kicked off this storm that we are seeing now. So I've watched almost all of his keynotes. They're available free on YouTube. So let's look at what he said last year. And he was comparing, this is a video that will follow, he was comparing the system he sold to OpenAI in 2016 to what was available 10 years later in 2025. If you could click and get the video going.
Really hard to do. Second generation, so much smoother. And this generation, look at this, completely cableless. Completely cableless. And this is all back in the lab now. This is the next generation Rubin. While we're shipping GB300s. We're preparing Rubin to be in production, this time next year, maybe slightly earlier. And so every single year, we are going to come up with the most extreme co-design system so that we can keep driving up performance and keep driving down the token generation cost. Look at this. This is just an incredibly beautiful computer. Now, so this is amazing. This is 100 petaflops. I know it doesn't mean anything. 100 petaflops. But compared to the DGX-1 I delivered to OpenAI 10 years ago, 9 years ago, it's 100 times the performance. Right here versus 100 times of that supercomputer. 100 times, 100 of those, let's see, 100 of those would be like 25 of these racks, all replaced by this one thing. Insanely hard to do. Second generation.
Okay, so that was incredible. You saw a room, this is 10 years, a room full of computers now fits in the palm of his hand. And that was last year. So let's look at, this is a long table of all of the advances we've come. He said petaflops, it's a way to calculate compute power, complex mathematical calculations. So he was, if you look at today and what's happening now, even he was wrong. It's 3,600 times an increase in petaflops. If you look at every single thing, every element in that table, there's exponential increase. We'll come back to tokens in a second. So in the last 10 years, we've had a 100x improvement in total system throughput, which is, if you start to combine the clever architectural designs, the extreme core design he talked about, and really the transformer engine, which was Google Transformer, that's what kicked off in 2016, 2017. Google Transformer took tokens and kicked off this whole ChatGPT, OpenAI, and really compressed Moore's law, what we would expect over 100 years into less than a decade. So tokens are going to be the new industrial commodity. It's a manufactured resource. They are the raw materials, the atoms of intelligence. Tokens have been around for a long time. I studied them in computer science 35 years ago. It's a way to create small bits of information. Even a word, it was used for natural language processing, compilers, and so on and so forth. It's a way you take a long word, you just break it into bits, and you understand each of the bits, how they fit together. The transformer from Google allowed you to look at it in parallel as a whole, as opposed to what I was studying, which was each individual token one at a time and sequentially building it out. Now it's massive parallel computing power. So scale is the advantage, and here's what's happening. 2016, the cost to generate 1 million tokens was close to the order of $200 or more. That's what OpenAI was paying NVIDIA. And we're now down to less than 10 cents for the same thing. So what does that mean? You can pretty much take in the future, don't worry about cost. You can take every sensor log that you can get, every geological record in a mine, you can process and generate tokens and build intelligence out of it simultaneously because the cost of thinking has gone down by 99%. That's really, really profound. Okay, somewhere this needs to click in some direction. Okay, so where are we headed? Again, Jensen talks about AI factories. So they're going from that the chip and the simplification that he talked about that fit on his hand. Now they're going to add the networking, storage, software, all of that to build AI factories, and they're looking to build out to hundreds of those. They're going to have training models, inference models, everything that's available, almost near simultaneously available to you. So that's where we're headed. What does that unlock? So to me, I look at it as limitless possibilities. Today, you have approximately 1 billion knowledge workers globally. With agentic AI, think of a tenfold increase to 10 billion agentic workers in the future that are supporting us and not only reporting what happened, but acting via autonomous decision loops And then that enables us to move from more static large-scale modeling and simulation to very dynamic digital twins. We've heard lots of amazing stories about, lots of amazing case studies about digital twins. But now imagine those happening for every subspecialty that you can imagine. The interesting thing is AI it came out of the software world, and it is disrupting the software world itself. Over dinner last night, I was mentioning that even though I used to program a lot in the 90s, it's probably been about 25 years since I wrote a piece of code. But this is the most exciting aspect for me, because I don't need to learn how to code anymore. Your AI agent is going to code for you. What you need to know is to understand the domain and to understand the technology. You don't need to really know how to code. So there are going to be ways you can accelerate delivery from business requirements, design, development, testing. It's all a matter of days and hours. It's no longer a matter of months. And it's interesting what that might enable if you start to apply it to different industries. So we've heard of software-defined vehicles, where really increasingly the highest value components in an automotive car is software. We're starting to see AI-defined vehicles. So AI controlling everything from the interface to the driver and passengers in a car. So you're going to be able to speak to your car and understand what the check engine light is really about. It's going to talk to you, but also about infotainment and other things in the car. In the medical industry, it's going to do fantastic things. It's already being applied to diagnose challenges and problems using any form of scans that you can get. And then also in the financial world, you've got algorithmic trading that's happening. And so they're putting real money behind AI trading. So if you think, going back to the earlier discussion some of you had around the financial value, people are betting millions and billions on AI agents. So they're not entirely wrong. There's money to be made there. So let's get to something that's closer to all of us. If you've heard of this saying that William Gibson, the science fiction author, the future is already here. It's just very unevenly distributed. And that's brilliant, because there are always cases you can find where, okay, somebody's done something incredibly cool and it's really, really valuable. It's generating a lot of enterprise value, right? So a few things that come to mind are the Siemens electronic factory, where they've taken robots in a manufacturing environment. They're using a robotic pick and place. They have vision systems, camera systems. They have digital twins controlling everything. And that's great. You hardly see a person. You don't actually need a person. But the people are there. They're the control centers. They're watching, and they're helping the system move. NVIDIA's Earth 2 is one of the largest weather AI tools for predicting weather. So the innovation there has been to take what was a metro level weather forecast and take it down to a kilometer basis. So again, fabulous and fantastic demonstrations of what AI can do. So coming to mining and energy, if the past decade and just starting to get into today was really about building the data foundation, data lakes, ERP modernization, connectivity, the next decade is, as I mentioned, is going to be AI native operations. And again, to quote Jensen, his words, this is where the physical and digital worlds will come together to drive real value. I'll talk through a few examples of where I've seen, and in some cases I've participated, but where I've seen these innovations happen. The basis for all of that is data, right? So you need to be able to get that data. You need to be able to have models trained on it. So the companies that invest in sensors, connectivity, and data, those are the foundational layers. They're going to do really, really well. That's where the competitive advantage will come from, because the rest of the stack is then what AI will help you build. You don't need to understand software. You don't need to develop this. So think about building the foundation right, and the rest then will build really well. I'll give a few examples. Some of these, and we've heard plenty of examples, so that's great. So some of the interesting things that always caught my attention: a self-learning concentrator. So how great is that? And this is where they're taking in information about the ore, again, getting a lot of data about ore variability and what's happening in, and before it goes into the plant, you're able to optimize how to process and treat the ore. They've improved recovery rates, reduced energy intensity, the operations can be safer, and the key insight there is this intelligent system actually results in performance leverage, right? So it's a great example. BHP, we've done some work there, and at PDAC in Toronto, Mikko Tepponen, the digital officer, talked about 3 big areas that BHP is investing in. One is you take geologic data and to accelerate exploration workflows. So a lot of the exploration workflows are now being AI transformed. The maintenance aspect, I think Peter has probably done some work here, but reducing downtime using predictive maintenance has been really, really impressive, the work that the team maintenance center of excellence has been doing. And then using digital twins like at Escondida, where they're understanding the ore and the variability in the ore and translating that into the digital twin in real time, being able to implement improved performance. So another interesting talk I've heard Gustavo Pimenta, CEO of Vale, say. He had listed 5 key drivers or pillars of their mine of the future vision. No surprises for guessing what the number 1 was, which was smart operations. And AI was at the heart of it. They've invested in establishing AI and innovation hubs. Their ventures unit is investing in external innovation and bringing that into the company in various forms. Brilliant idea. Just a couple of use cases. I think I've heard almost all of these use cases discussed today here, so I think that's good. Perhaps a little bit less, I haven't heard anyone talk about generative exploration, which is use of AI to look at all of the geological, geochemical, geophysical data to really create a digital twin of the ore body and the deposit. So I think that's happening. It's happening in oil and gas. It's happening in mining. So I think it's going to be very important for companies here in Peru to start to utilize that aspect as well. We heard a lot about dynamic mining optimization, processing, and then also I was pleased to hear the circular resource management, which is understanding energy and water balance using digital twins. All right. I'm going to talk about a few cases in the energy industry. It was fascinating as I was looking at Peru and the energy industry. Geothermal is not very cost competitive here. I mean, there's a whole bunch of reasons, but what was interesting is that a lot of these geothermal deposits are co-located where there's active mining work going on, so that might be a future opportunity. But really, the application of Zanskar is doing what the oil and gas people have done. They've created digital twins of the underground ore body, so they're taking in seismic data, they're taking in geophysical data, and then they're really mapping and understanding where the heat zones are, so you can go and exploit the heat zones to capture that geothermal energy. Duke Energy is one of my favorites. So this is called the self-healing grid. So when there's a thunderstorm, oftentimes downed trees will cut power lines, you lose power. So they have a grid that's able to understand and predict either seconds or milliseconds before something happens, and they have the ability to close some things so that when the actual event does happen, if the power line goes out, that the grid is still somewhat stable, and as the best it can until a physical intervention is made, it's able to heal itself. They've had some fabulous success in terms of reducing power outages to less than 1 minute. So oftentimes people don't even realize that there's been a power outage. Another interesting one I thought was very similar to what mining operations are, thermal efficiency or heat rate. This is a power plant. And as you can imagine, it's the heat rate is an efficiency factor. Even a 1% change can make a real impact. And to not only profitability, but also CO2. So traditionally, this required a human operator to set a number of different variables, pressure, oxygen, fan speeds, etc., while you're constantly battling in a changing dynamic around you, which is humidity and the environmental factors. So now, perfect example to take this and have an AI help you orchestrate these settings for improved performance. But before we do, I'm glad a number of speakers talked about these. There's two gaps that an AI system really does need to address, right? First, I would call it the trust gap. What about privacy? What about IP protection? Will my data be, will others be able to access my data? Cyber physical security, we heard a number of speakers on cyber security, not only about privacy, but could your infrastructure get hacked? It could. So you really need to be, you need to have the guardrails for those. The trust deficit is important. How do you trust an AI that can't explain its recommendations or can't reproduce it? So that's going to be important to include in and bring into consideration. And then for certainly an important consideration is data sovereignty. So where does the data live and who controls it? The industrial brain is a valuable commodity. Where is it going to live and what are the access rules? Is it going to be some level of shared resource, perhaps through a consortium, depending on the application, of course. Those are all real issues that would need to be addressed. There is also a reality gap, right? We've seen this. Sometimes if you ask ChatGPT, and one question that my daughters and I have tried is, you ask ChatGPT, you tell it, I want to go to a car wash, which is about 50 yards away. Should I drive or should I walk? It's probably, they may have changed it. We did this experiment last month. It said, well, you should walk to the car wash. It's only 50 or 100 meters away. So again, the context isn't there, right? And some of the other search engines or AI engines did a little bit better, but how do you trust, how do you get, if a large language model fails at simple spatial reasoning, how do you know it's going to really deliver on understanding the fluid dynamics within a concentrator plant, right? Is that even possible? Should you even consider? Answer is yes, there are ways to do it. You bring in the physics, you bring in the chemistry. So you utilize physics-informed AI. Don't rely on pure large language models, right? And then there's this other really important term, RAG, Retrieval Augmented Generation. It's a fancy word. All it means is go look at the documents that really describe what the system is. Don't just reach into the universe of everything to pull the answer. Here's the textbooks you should study first before jumping to the answer. So retrieve the information before generating the answer. So those are ways that systems are now utilizing so that you could improve the logic and not be tied into hallucinations and so on. Safety is a really important one. Many of you have talked about physical catastrophes, if that causes uncontrolled machinery or a grid collapse. Yes, so that's has to be taken very seriously into account. Human in the loop is one of the best ways to build trust and also address the safety aspect. But also, if you're in a simulated world, you can run multiple simulations. You could almost try every possible scenario in a digital sandbox before getting into the actual world. getting to the last part, so how do you accelerate all of this? And this is where it starts to get really, really fascinating. So modularity, I think, is going to be very important. The past experiences, I really like digital twins because the digital twins allow you to simulate the future, right? And agentic AI by itself is not going to allow you to simulate. But an agentic AI, if you saw the first part of my presentation, the agentic AI can do now things so fast, and you can build them so fast. A digital twin could take months, years, millions of dollars to build. It is a very worthwhile investment because it allows you have to build that in order to simulate. But an agentic AI system can get you going right out of the box and get you, you can build an app instantly within order of minutes now. I'll talk about that as well. So modularity, focus on the high value problems, target high data streams. Don't try to get everything in. Start where the value is. And then go to a co-pilot kind of mode. Go to a shadow mode with humans alongside the AI. I won't do justice to most companies on the planet, but I just pulled a few that either I have experience working with or experience in implementing and working with some of these. And I made an update to this table just a few days ago. Tasklet. It wasn't Tasklet, the last one. It's not a mining tool. It wasn't even on my radar. Just like some of you have seen OpenClaw. OpenClaw went from nowhere in November 2025 to one of the most popular apps. Tasklet is something similar. It's incredible. It's no-code agentic orchestration. I'll talk about it in a minute. So let's look at how you could pull some of these things. If a maintenance supervisor at your site receives an abnormal vibration SAG-mill alert at 4 a.m., right? Of course, when else will this happen? You're going to have to log into an enterprise asset management system, ERP, SAP, pull vibration histories from Pi, look up, in shared drives, look up the PDFs, etc., or go talk to an expert, a human expert. So all of that's going to happen. Let's play this real quick. By the way, this video was, I did this video, it took me less than 5 minutes to do, and it's a short loop. But these alarms are going on, and you're trying to really log into different screens. You're trying to understand what information to pull from where. And in the meantime, the vibration alerts on the SAG mill, if something happens, you know the cost of that. It's going to be to the order of $100,000, $150,000 per hour, right? But if you're able to have an AI orchestration agent on top, it's going to be able to do the lookups from SAP, from Pi, from unstructured PDF data. It's going to be able to and give you an answer as a maintenance co-pilot that you just say, I approve this action, and I'm going to perform that now. That's real value. So with Tasklet, you could probably write this. The integrations, maybe they'll take a little bit longer, but that app is an app in an instant. So order of minutes, you've built an app. No coding required, no APIs needed. You don't need APIs anymore. For those of you who are OEMs here in this room, I think you'll understand what that might do to your business models. APIs are not going to be required. They're always going to be a better way to function. But Tasklet, again, this is not an industrial mining app. It's like an OpenClaw app out there. It's going to be able to sniff out the appropriate interfaces to connect to your systems, and it's going to be able to connect to it without a well-defined API. So underneath now, you can still have the spaghetti and meatballs of all your disparate systems. You don't need to unify all of those. You don't need an orchestrated solution that takes in and makes everything seamless. You let Tasklet or an agentic AI do that for you. it's going to be the orchestration agent on top. No-code authoring, it's what I'm most excited about, keeping the human in the loop, and then having that expert tier to validate what's happening. With that, I'll end with a playbook. It's about the human system leadership, understanding what these digital skills are. And final reflection is that it's not about replacing the human element, it's about amplifying it. It's about bringing those 10 billion AI agents with us so that the 1 billion of us, hopefully more, knowledge workers can do better. So that, I'll turn it over to you, Manuel. Thank you.
Thank you so much.
Appreciate it.
Thank you for your outstanding presentation, Satish. Unfortunately, the time ran out, so there's no time for questions, but outside, of course, you will have a lot of questions from the audience. We have a kind present for you. Thank you so much for being here and to develop this great presentation.